Next team is getting to know your friendly neighborhood rooftop, the Javits Center green roof.
Hi, my name is Keegan, and this is my teammate. And George is joining us from the Highline team to kind of do a portion of our presentation with us. So we worked together this semester on various different final deliverables for the Javits Center. So this is just a brief outline of our presentation. We're first going to just give a brief introduction of the Javits Center itself. We will then present our final deliverables, and then Mairead and George will present our joint team project on the urban heat island effect, and then we will have our conclusions and recommendations to our client. So the Javits Center is actually the largest convention center in New York, and it's located in Midtown Manhattan. The center completed its 6.75-acre green roof in 2014, and it just reached maturity this past year in 2018. The green roof represents the center's commitment to improving the local urban environment, and the ecological benefits of the green roof include urban heat island reduction, stormwater retention, species habitat, and energy savings.
So based on early communications with Javits Center Sustainability and Energy Manager Rebecca Marshall, the team formulated and defined the following questions that address existing needs at the center. How has the Javits Center green roof impacted the local urban ecology? How can we quantify and instructively measure this impact? How can we communicate this impact to the public? And how can we best serve operational needs? So our team was able to translate this into 4 final deliverables: a comprehensive green roof map, an urban heat island impact analysis, a roof tour brochure, and an internal report provided to senior management.
So for our first deliverable, we have a GIS roof map. So there are many different departments, contractors, and researchers that actually work on the roof, and they all use different maps. So this emphasizes the need for universal symbology and terminology. So we created GIS maps with various different layers, and these layers included working components on the roof, such as HVAC units, Drexel University research equipment, the irrigation system located on the roof, as well as the herring gulls nests from the years 2015 to 2018. These herring gulls nests have actually been increasing each year since the roof was completed. And now they are now interfering with the work and maintenance that occurs on the roof. There are now over 100 herring gull nests, which emphasizes the need for these maps to assist in a gull management plan. So on the right, we have one of our static maps that we created. It's highlighting the gulls nests from 2018, which is this past year. And then this static map actually shows us the irrigation systems and Drexel University research equipment on the roof. In addition to these static maps, we also created an interactive web map through ArcGIS Online, in which these layers can actually be turned on and off. So for our second final deliverable, we worked with the Javits Center to articulate an ecological narrative and expand its reach through a physical and digital brochure. The content in both of these brochures actually integrates information from the Javits Center Sustainability Report, Green Roof Researchers Alliance, and as well as research within our own project.
So our internal report was delivered in 2 final packages per client specifications. In the first one, we provided sustainability management with a comprehensive 40-page report that spanned the breadth of our methodology, analysis, instructions for proper use, and final recommendations. And then to the Javits Center board, we provided a synthesized and condensed overview of our project and its larger significance. So our final deliverable is a joint project with the Highline. It is the Urban Heat Island Impact Analysis. This project was spurred by a desire to quantitatively measure and represent a more nebulous but high-value aspect of green roof performance, which is urban heat island mitigation. And so the urban heat island is the phenomenon wherein, as a direct consequence of urbanization, urbanized landscapes exhibit temperatures that are 2 to 6 degrees Fahrenheit higher than their non-urban surroundings. So because the Javits Center belongs to a class of infrastructure termed green infrastructure, one part of its performance is being used as a strategy to moderate the urban heat island. The Javits Center is not alone in the neighborhood. There's a local network of such green infrastructure, such as the Highline's Elevated Green Park and the NYPD Topaz Reflective Roof. As these sites have been introduced in close proximity to, both temporally and spatially, the team saw an inroad for measuring their compounded impact on the urban heat island. So this project sought to address the following question: how has the concurrent introduction of green infrastructure in a single neighborhood mitigated the urban heat island effect? So the team accessed data through the Landsat Remote Sensing's 46-year archive, and then we processed that through ArcGIS software to calculate values for land surface temperature and vegetation. We ask that the audience interpret our findings cautiously in light of some limitations with the instrumentation and data collection process. And this is George.
So, what did we find? In this slide, we see 3 maps of temperature change over time, and that's land surface temperature. That's basically how hot was the sidewalk in 3 different points in time. The first map shows 1984 to 2018. All the blue areas are areas of decrease. The white areas are basically neutral, no change, and the red areas are areas of increase. Now, from 84 to 2018, overall, you see mostly there was a decrease or neutral, but that doesn't really show us the full story because so many different things happen in that span of time that it's almost impossible to isolate, one specific variable. But if we look at 02 to 14, we see a kind of a reversal, and so it's kind of a neutral to increasing trend across the map. This was a period during which the High Line was being built. The Javits green roof didn't exist. And so, those are 2 variables which could have contributed to the land surface temperature here increasing. Obviously, there's so many other things that were going on at the same time. But if we look at 2014 to 2018, we again see a significant decrease, even more significant than the period as a whole from 84 to 2018. And although we weren't able to really identify exactly what caused that decrease, we think that it's possible that vegetation played a role in that. So if we look at the next slide, this is showing basically what happened in the mean temperature over time. And you see that generally it fluctuates above and below the average. What's interesting here is if you look at the last bit, 2014 to 2018, we've had the longest sustained decrease in temperature throughout the whole period. And so that could be indicative of a trend that's happening now that, for some reason, the temperature in the neighborhood is decreasing. Here we have so the next slide is going to be showing vegetation change, but the way that we were able to find vegetation change was actually pretty interesting. So when the light from the sun hits plants, certain wavelengths will be reflected, and we're able to detect those wavelengths using satellite imagery. And so based off of the wavelengths which are reflected, we can actually map out exactly what's on the ground, whether that's concrete or asphalt or plants. So in this map, we see the next map. So the next map, we see change of vegetation over time. So, green is increase, red is decrease. I'll draw your attention really to the middle map where we see dark green over the building kind of on the top left corner. That's the Javits Center. So we were able to detect basically that when they built the green roof, which was in this period of time, there was a significant increase in vegetation. And, over time, there's been areas that have had more vegetation, less vegetation. When we ran a regression of, what happens with vegetation versus what happens with land surface temperature, we couldn't find any sort of statistical significance. So that doesn't mean that there's no relationship between, having more greenery and potential decreases in temperature in neighborhoods. It just means that we could improve it. So for those of you here who are not seniors who will be continuing on with sustainable development, this could be an exciting problem for you to take a look at. Can you find additional data that could prove that, vegetation leads to cooling temperatures?
So in conclusion, our recommendations to our client include transcending our scope, bringing it forward into the future. So for example, continuing to add layers to the GIS maps to efficiently maintain the ecological benefits of the green roof itself. And secondly, tailoring and distribution. So continuing to hand out brochures and information to visitors so that people are aware of the outstanding sustainability work that the Javits Center has completed.
Another recommendation from our team is for the Javits Center to join forces with Green Infrastructure Local Notables to work together on a narrative that sort of talks about their joint impact in mitigating the urban heat island effect and its community of life its quality of life and community resiliency benefits. We also would suggest that the Javits Center use this cooling effect that it's had on the neighborhood in order to filter into its existing narrative about as an ecological success story.
Thank you. Are there any questions?
On the Javits roof, I would encourage you to take a tour. It's quite an experience.
So some of us in the audience are bicyclists, which means that we've got a zero carbon footprint when we ride our bikes to the Javits Center, which is controlled by New York State and Governor Cuomo, not Mayor de Blasio. And since it's the largest convention center in New York City, the Javits Center does not have one bicycle rack there for people to lock up. And I'm not talking about city bikes. I'm talking about the fact that I've been asking various public officials to put some bicycle racks. So if you're going to look at a green footprint, you've got to look at not only the roof, but the people that are coming on their bikes. So I would like to make the suggestion to your committee to contact the Javits Center and Governor Cuomo and say, what about putting a few bicycle racks for the people that are putting out zero carbon? Thank you.
I can address that very shortly. Our scope was more on the green roof itself, not on the sustainability of the Javits Center as a whole, though in the last few years they have added a city bike station, as well as the fact that the Hudson Yards subway station was built nearby very recently. There are much less cars going to the Javits Center. Most people get there by bike or by subway at this point, unless they're coming from outside of the city. But again, our scope was more the green roof itself, not the sustainability of the Javits Center as a whole.
Hi, I was curious on the figure showing the direct land surface temperature trends, maybe especially, for example, that one 2014 to 2018 on the far right. What's the relationship between, the weather and temperature, over that 5-year period relative to that direct surface? Could some of what we're seeing be random variability associated with climate as opposed to the direct effect of the sort of surface itself?
Before we address the question, can we get the slides back up, the projector?
So when we were doing these calculations, we normalized for changes in temperature. So we made sure that the days that we were comparing were, first of all, they were all in August. So there was a similarity in the season, but also the temperature on the day was also similar. So certainly, if you compare days that have different cloud cover and different temperatures, you could have basically useless data. But one of the challenges we had was ensuring that all the dates that we're using for comparison were consistent. So that is certainly a good point, though, to bring up.
You mentioned that the bird population or nesting was happening. Was there any other types of pests or insects that might have posed a threat to or an issue with in developing a green roof?
So the goals on the roof, the nests are not an issue per se. In 2015, there were only 11 nests. The Javits Center used to be famous for being a bird killer, and since they installed their green roof, they also installed bird-safe glass. So they have reduced the amount of birds that they kill, not only reduced the amount of birds that they kill by over 90%, but also are now a bird habitat. The problem is not pests on the roof. The problem is that when it became an overwhelming number of birds and bird nests on the roof, they started the herring gulls are incredibly protective of their young, and so they started interfering with, it's both a green roof and a working roof. They started interfering with people working on the roof, servicing the HVAC units or the irrigation system and whatnot. And that was one of the driving factors behind our motivation of mapping out both the gulls' nests and other components of the roof together, so that the Javits Center leadership can see this all in one map, as well as distribute it to all of their contractors and researchers.
And just to add a bit to that, so there are a number of other species that use the roof as a habitat as well, such as bats, insects, fungi, a range of different fauna and flora, but none of those have been identified by the Javits Center as something that they're concerned about as being part of the roof and its vegetation.
Any other questions?
Yes. Can you address in some small way what is the resilience factor or possibility of a green roof for an extreme weather event like Hurricane Sandy compared to, say, an equal amount of actual terra firma ecosystem? You know, is there anything built in to preserve it?
Every winter, they winterize the roof. The roof actually retains 81% of stormwater. So instead of running off into the sewage system and overflowing into the river, it retains 81% of that stormwater. Obviously, in an extreme weather event, it won't retain 81% of everything like in Hurricane Sandy, but it can still mitigate the amount that is running off. I'm sorry, I don't know if I understood the second part of your question.
No,
that was it? All right.
I'm curious if you looked into the impact that the Javits Center green roofs had, like on other buildings in the area and in the city in large, or overall, and if green roofs have gone up as they've seen, some of the results that the Javits Center's gotten.
Would anyone else like to take this, or should I? So the Javits Center currently makes up 10% of all green roofs in New York City, and they have been part of an effort by the Green Roof Research Alliance to catalog every single one of the green roofs in New York City. It's a very recent project, so it's impossible to tell how much it has grown. Because it's still in its beta format. But as this research grows, we will be able to see how, I don't know if the Javits Center has a direct impact on the amount of green roofs springing up in the area, but there are other green roofs in the area, even beyond what we mentioned, the High Line, which could be considered a green roof, and the NYC Toe Pound, which is a white roof, but it's still green infrastructure.
Okay, thank you very much.